to start chapter 5, which is of course some more trigonometry, and it's analytic trigonometry. So we get to analyze some trig identities and come up with some explanations behind them. Sound good? So 5.1, we get to do some verifying of some trigonometric identities. So we're going to start looking at some of the identities that we learned from chapter 4 and then apply those, including that Pythagorean identity. Pretty much we're going to be using a whole bunch of substitution to be able to show that these identities are true. Sounds exciting, doesn't it?
No.
Oh, yes it does. All right. So if I were to give you guys, like 1 foot, that would be the same thing as 12 inches, right? You guys agree those are the same thing? Yeah. If you had to make an educated guess on how many centimeters 12 inches are, what would you say? 24?
No, definitely 22.
All right. So if I sat there and said I would give $100 to the person who had the best estimation of how many centimeters are in 12 inches, you would say?
48.
48? 100? 22?
1,000.
You only get one guess.
124.
124. I think it's like a 30.48 centimeters, right? Isn't it like 2.54 centimeters per inch?
Who was closest?
I was.
Oh, you get full. Because you knew the answer.
I didn't know the answer, I guessed. Because I said, I think.
Oh, I thought you would have already knew that though, because you're a math teacher.
No. Right. So these are all the same thing, right? They're just written in 3 different forms or 3 different ways. So that's really what we're going to be doing when we go through these trig identities, is it's going to be the same thing. They're all going to be equivalent. They're going to be equal. We're just writing them differently. So it's an English lesson today. Not really. All right. Chapter 4, we went over some identities. We did the reciprocal identity and we did the Pythagorean identity, right? So we're going to write those down again just to refresh our memory. Sound like a plan? So you guys remember all of your reciprocal identities? Reciprocal identities. And so if I gave you, I don't know, what do we want to start with? Cosecant? What was cosecant the reciprocal of? Anybody remember? 1 over, I heard somebody say it.
X.
Sine of x. Remember that? And if I had secant of x, the reciprocal of secant of x was 1 over cosine. Yep, good job. Right. Anybody remember cotangent? 1 over tangent. Yep, good job. 1 over tangent of x, right? And then since we're looking at reciprocals, we can even list these going the opposite way. If I wanted to look at sine, I could write sine as 1 over cosecant of x. And I could write cosine of x as 1 over secant of x. And last but not least would be tangent of x. And tangent of x would be 1 over cotangent of x. Right? So these babies all mean the same thing. We're just writing them differently. So if I want to write if I have cosecant and I don't want it written as cosecant, I could just substitute in 1 over sine of x, right? Just making that substitution. We call another identity called quotient identities. So in mathematics, what does the word quotient mean? Division. Yeah, division or a fraction, right? So quotient identities. And there's only 2 of them. And you guys know, you actually know these, right? If I took the tangent of x and I wanted to write tangent of x as a quotient, do you think this would be sine of x over cosine of x? Yeah, remember that? Yep. So what would the cotangent of x be?
Cosine x over sine.
Look at you, rock stars. Yep, cosine of x over sine of x. Good job. Awesome. Not too bad. All right. And then that last one that we went over with in chapter 4 was that Pythagorean identity. So let's write that one down as well. Just a little refresher. So when we were talking about the unit circle, we came up with the Pythagorean identity. Anybody remember what it is? It was like
It's like cosine of x squared plus sine of equals 1.
bam! Look at you. What do you need me for? You guys got that one. Yep. All right, cosine squared of x plus sine squared of x equals 1, right? So when it comes to the Pythagorean identity, we can even rearrange this good little stuff that we have up here. And it's all going to mean the same thing. If I wanted to solve it for, you want to do sine first or cosine first? You pick. Cosine. So if I want cosine of squared x, and I want to know what that equals, how would I solve that for cosine squared? What would I do? What is my goal? Like if I don't want to take the square root because I still want that baby to stay squared. So I just want this piece. So what do I want to get rid of? I want to get rid of sine squared. How am I going to get rid of sine squared? Subtract it. Yeah, subtract it from both sides, right? So I end up with 1 minus sine squared of x. Right? And if I wanted to get sine squared all by itself, what would I do to get sine squared all by itself?
Subtract cosine.
Yeah. 1 minus cosine squared of x. Right? So if I'm going through these little identities and I see like 1 minus sine squared of x, I know I can make a substitution and just put cosine squared in there if I wanted to. Right? And then there were 2 other ones that we have. We're not going to use them per se today, but we will be using them. And you guys might even have to prove these for me. The one was 1 plus tangent squared of x equals secant squared of x. And this third one would be 1 plus cotangent squared of x. See if you could use some critical thinking skills. What do you think that one's going to equal?
Cosine.
Look at you. Yep, cosecant squared of x. All right. So you ready to try and apply these to our little section? You're like, why am I writing all of this down? I'm like bored out of my mind. I know all of these. What am I going to do with them? Well, let's find out. Sound good? So excited. You guys excited? We're going to do some verifying. So they will ask you to verify the identity. And they don't walk around with like ID badges, so we actually have to do some work to be able to identify them. to verify their identification. All right. So if I were to give you, or if I were to tell you that secant of x times cotangent of x, I know that that equals cosecant of x. Do you believe me?
No.
You don't believe me?
No.
No? All right. So when it comes to us working through these little identities, couple goals are in mind. I usually have them all set up to you guys to where we're going to play around with and we're going to manipulate and we're going to do substitutions on everything that's on the left-hand side of our equal sign. And we're going to leave the piece to the right the way that it is. Okay? So the only thing that we're going to be messing with is this left side. And our other goal is we love sines and cosines. We're all going to say that together. You ready? We're going to say, I love sines and cosines. Ready? 1, 2, 3. I, that's you guys. I love sines and cosines. Yeah, you forgot the I part though. Let's try it one more time. You ready? I love sines and cosines. Good job. So everything that is on this left-hand side, for the most part, we are always going to try to get it into terms of sines and cosines. And when we can get all of this into sines and cosines, it makes our life a lot easier. All right? You ready to try and hammer this one out? Yeah. So I'm going to start with secant. Right? So I'm going to take secant and I want to rewrite this with what? Sines and cosines. Can I rewrite that as a sine or a cosine somehow, shape, or form? Yeah. How can I write secant? 1 over cosine of x. Yep. So 1 over cosine of x. I can't drop anything in my equation. I still have that multiplication. And then now I'm on to cotangent of x. How am I going to rewrite cotangent of x? Which one is it? We could write it over 1 over tangent, but our really goal is to get sines and cosines. Could we write it with sines and cosines? Sine over cosine? Or cosine over sine? Well, you gotta know.
Cosine.
I like that one better, yep. Cosine of x over sine of x. Oops, that's a really bad sign. And we're just going to keep this, right? Equals cosecant of x, because that's our goal. So we're just playing around with the left-hand side. Is there anything I can do on the left-hand side? Yeah. Yeah, cosine over cosine is 1, right? Anything over itself is 1. So cosines. And then what am I left with? 1 over sine of x. And we're hoping that that equals cosecant of x. And what's 1 over sine? Cosecant. Cosecant of x equals cosecant of x. Told you they were equal. Right. So a couple things. When it comes to your guys' homework, you could write out the problem, and then you could jump right down and tell me that, of course, cosecant of x equals cosecant of x. That ain't going to fly, right? So when you guys are doing your homework, all of this garbage in the middle, you got to have that on your paper. Make sense? Because anybody can say, oh yeah, I know that cosecant of x equals cosecant of x, duh. Right? But it's going through all of those steps to prove it or to verify is really where your work is, right? Huh? Felt it, didn't you? Exactly, absolutely, right? So, going back real quick to Gracie, how Grace sat there and said that, you know, how, and this is true, like how cotangent of x, how we thought that was 1 over tangent of x. It absolutely is, right? And our goal is to get this in terms of sines and cosines. So you still can keep working on this one, because this would be 1 over, how can you write tangent as terms of sines and cosines? Sine of x over cosine of x, right? And then if you're dividing by a fraction, you got to multiply by the reciprocal. So that's going to equal 1 times cosine of x over sine of x, right? Which is the same thing that we ended up getting over here, right? Because 1 times it's going to be the same thing. And that's perfectly fine. It's just going to take you a couple extra steps, right? So, and that's perfectly fine. If you don't see the connection of getting straight to a sine and a cosine, you might have to take an extra step in there, and that's perfectly fine. Sound good? You want to try another one? Yeah, Mrs. Fitch, these are fun. These are awesome. I love these. Love these. All right. What if we had cosecant of x times the tangent of x, and I told you that was the same thing as secant of x? Are we ready? What are you going to do? What are you going to... You tell me how to do this problem.
1 over sine of x times sine of x over cosine of x.
Man, you're on top of it, aren't you? All right. Equals, and we're going to keep that side, we're going to keep the right the same, right? What do you guys notice? Cross cancel those signs, all right? Whoops. We're left with 1 over cosine of x, which equals secant of x, and 1 over sine of x is secant of x equals secant of x, okay? So do you see how the second problem was a lot easier for you guys to do than the first problem?
That's how learning goes, right?
Yeah, because you practiced.
Right.
And then as soon as you did that practice, you're like, oh yeah, look at that. It got a little bit easier. Not the easiest, right? But hey, it got a little easier. So see, practice. All right. I'm ready for some spice. So let's say I wanted you to verify that cosine of x minus cosine of x times sine squared of x equals cosine to the third of x. All right. So that cosine a third to the x, what does like cosine to the third mean? It just means it is cubed, right? Cosine times cosine times cosine, right? So our first goal is always to try and get this in terms of sines and cosines. And what do we got going on in this one? Do we got all sines and cosines on the left? Yep, so I think we're good so far there. So then the next thing I do is I always look at my degrees, and I got a square in there. And anytime I see a square, if we just think of those reciprocals, we didn't have anything that was in there that was a square, right? But when we looked at the Pythagorean identities, there were squares, right? So that's where I'm going to kind of lead to a little bit. But when it came to those Pythagorean identities and those squares, woo, right? Like I have kind of like this pluses and minuses and all that good stuff. So on my problem, when I look at the left side, because it doesn't quite fit quite yet into one of my Pythagorean identities, is there anything I can factor out? Yeah, I could factor out a cosine of x. I wonder what happens when I do that. So if I factor out a cosine of x, so cosine of x times what's going to get me to cosine of x? 1 minus cosine of x times what's going to get me cosine of x sine squared of x?
I'm getting a little bit lost, not gonna lie.
Sine squared, all right? So you're factoring out cosine, right? So I'm taking these guys out. So when I factor out a cosine, right, cosine times what is going to give me the cosine of x?
Oh, okay, I thought we were doing
Right.
like the whole thing, okay.
Yep, right, minus, minus, right? Cosine of x times what is going to get me my cosine sine squared of x? Right? You good with that? And we want to show that that equals cosine to the third, right? So now on my little piece that I have like factored out, does any of that match up with anything that I have? Back here to my identities? So, do I have a 1 anywhere? Do I have a cosine squared? Do I have a 1 minus sine squared? Do I get a 1 minus cosine squared?
The cosine squared x equals 1 minus sine squared x?
This one?
Yeah, that one.
Yep, because we had that 1 minus sine squared, right? So wherever we see 1 minus sine squared, what could we put in?
Cosine squared of x.
Cosine squared of x. So here's my 1 minus sine squared of x, and what does that equal? Cosine squared. So yeah, cosine of x, right? Gonna make that substitution of cosine squared of x. And we want to hopefully prove that that equals cosine third of x. Cosine times cosine squared is? Cosine to the third. Yep, cosine to the third of x. And that equals cosine of third to the x. So we verified that those two statements are equal, right?
How did you get rid of the sign? How did you get this cosine squared?
So when you look at your Pythagorean identities, what's cosine squared equal? Cosine squared, right? So where our 1 minus sine squared was, we just substituted in cosine squared. Yep. Yeah. See how they take a little bit of practice to kind of get used to what's all going on up here? Right. And there's more than one way to do these. So don't feel like you have to. Like you could have left it if you didn't want to factor out that cosine. Right, and you have, oops, let's go to cosine x minus cosine x sine x squared equals cosine a third of the x. If you didn't want to factor out that cosine to begin with, you know what sine squared is, right? If you went back to your Pythagorean identities, and sine squared is 1 minus cosine squared. So you could have made that substitution. So you would have had cosine of x minus cosine of x. And then where there was a sine, you would have put 1 minus cosine squared of x. And we're hoping that that equals, right? And then now you could have multiplied through. So you would have had cosine of x minus cosine of x plus cosine to the third of x. Right? Just using your distributive property. Am I good so far? You guys good so far? And then now I could simplify that. Right? Cosine x minus cosine x. Nothing. Plus cosine to the third of x. Right? So I don't want to tell you how to do your problems. I want you to figure those out, right? Want to try one more? Give you one more little craziness. What if we had, they can either use x's or thetas. It means like the same thing when it comes to doing these identities. So if I gave you tangent theta plus cotangent of theta, and I want you to verify that that is secant theta cosecant of theta. Don't let the thetas be your hiccup. If you want to switch those babies to x's, switch them to x's, right? I just feel fancy when I make them. I feel smart. All right. So what side are we going to play with? Our left side or our right side? Yeah, we're going to play with this left side. And we want to try to change these all into sines and cosines, right? All right. So what do we want to do with tangent? Yeah. Sine theta over cosine of theta. I'm good with that. Plus cotangent. What do we want to do with cotangent? Cosine theta over sine theta. And we just want to verify that it equals all the stuff that's on the right that we're not going to change. Wonder what we could do now. Do what? Oh yeah. These ones are being added together, right? So we can't cross cancel. I know. So so those two things are fractions. Good job. Beautiful. And when we add or subtract fractions, we have to have a common denominator, right? So I got to look at my denominators. So what do you think a common denominator is going to be? Sine times cosine, right? So I'm going to start off by writing it as two fractions, right? So I want to go with cosine theta sine theta plus cosine theta sine theta, right? They're the only things that they have in common, right? That common denominator, right? Almost think of it if you had, I'm just gonna, like 1 over 7 plus 1 over 13, right? Most likely you're gonna do 7 times 13 to figure out that common denominator. Right? Right. So I originally started with sine theta on top. So what did I have to multiply my denominator by to get that first fraction? Sine. So if I multiply the bottom by sine, what do I got to do to the top? Multiply it by sine. All right. And my second one, my original had the cosine theta. Yep. What did I multiply my denominator by? Cosine. So what do I got to multiply the top by? Cosine theta. Equals secant theta cosecant theta. So now I'm going to write it as one fraction. Sine times sine is sine squared. Plus cosine times cosine is cosine squared. I forgot my theta. Plus cosine squared of theta all over cosine theta sine theta, right? Equals secant theta cosecant theta. Right. So now what do I notice about my exponents? Is there a square? Yeah. What usually helps us with squares? What kind of identity? Pythagorean identity. So can we do anything with sine squared theta plus cosine squared theta? It equals 1, right? So now I have what? 1 over cosine theta sine theta? I'm trying to get this thing to equal 2 guys, right? So could I take my fraction and split it into 2 guys? Yeah, I can split this into what? I'm just gonna, oops, we're gonna go down here. 1 over cosine of theta times 1 over sine theta. And we're hoping to get that to be secant theta cosecant theta. Right? Can we do anything with 1 over cosine?
An equal secant.
Oh, it equals secant. Look at you. Secant theta. And what about 1 over sine? Huh. That's cosecant theta. And the stuff that we had on the right, is that the same thing?
Yeah.
Bam! Verified.